Hello, Facebook world. It's your boy Veal, once again, president of It's Not Complicated Tutoring. Apparently, my clients are sick today, so I'm gonna go ahead and do another video, or maybe a set of videos for y'all on derivatives once again. So yesterday we kind of recapped a little bit, if you will, on derivatives, on the introduction of derivatives and the power rule, constant multiple rule, things of that nature. So I'm going to go a little bit further on the lesson today for another 14 minutes or so and see if we can go ahead and get that knocked out. So let's look at some things. Alright, so yesterday we talked more so about regular derivatives. Let's use a derivative, though, to justify the power rule for n equals 2, or n equals negative 2, actually. Alright, so use the definition of a derivative. Use the definition of a derivative, alright, to justify the power rule for n equals negative 2. Now, the way that we're going to do this is to take f of x plus h minus f of x all over h. It's called the definition of a derivative. It looks something like this. F of x plus h minus f of x, the whole function, all over h. I'll give you a second to kind of look at that if you want to see how that looks. As you can see, that's the definition of a derivative. Alright, now look at a couple more things. So the shortcut way is to take x to the negative 2. It's basically x to the negative 2. So I want to know the derivative of really x to the negative 2. Okay? We can use the power rule and take the negative 2 over to the left here to get negative 2x to the negative 2 minus 1. Remember yesterday we talked about minus 1. So negative 2 minus 1 will be, that's right, negative 3. So negative 2x to the negative 3. In addition to that, we talked about negative exponents. If we have a negative exponent, the item here can go from x to the negative 3 to 1 over x, the variable, to the positive exponent, which in this case will be 3. We multiply this together, so we get negative 2 times 1 over x to the third. Which is negative 2 over x cubed. That is the regular power rule derivative. The shortcut. Let's go the long route and see what we got with the definition of a derivative. Alright? So, here we go. The limit of x as it goes to 0, or h as it goes to 0, alright, of x squared, or actually, in this case, it would be the derivative of 1 over x squared. So, same thing here, the derivative of 1 over x squared. As I do this with the definition of a derivative, I'm going to do this right here. The limit as h goes to 0 of 1 all over, and we replace every x that we see with x plus h. So x plus h squared right here minus 1 over x squared, which is the actual function itself, all over h. Alright? Let me let you take a look at that real quick so you can see. As you see here, I have the limit as h goes to 0 of 1 over x plus h quantity squared minus 1 over x squared, which is the actual function, x to the negative 2, all over h. Alright? Now, what I'm going to do is simplify this right here. So this then turns into x squared. And in this case, I would actually take the common denominator of these two. So it's x squared times x plus h squared over here. X squared times x plus h squared over here. And I cancel out what's common. Remember back in the day when you did your rules for, let me say, your rules for fractions, okay? We definitely needed to find the common denominator of both of our fractions. So in this case, it's x plus h squared times x squared. We cancel out what's common. We got x squared over here minus x plus h squared, quantity squared, on that side, all over x plus h squared times x squared, all over h. Alright? And you can't leave out your little limit over here as h goes to 0. For all them AP sticklers out there on the AP test, they'll get you for that. Alright? Watch your step. Now, at this point here, what I'm going to do is take the fraction. I'm going to actually simplify first. I'm going to take this and expand it out. Then I'm going to, when I divide by a fraction, I multiply by the reciprocal. So here's what it's going to look like. Alright? I multiply this right here times 1 over h. So I then continue over here. And I'll do this in another color so you can see what it looks like. X squared minus x plus h squared all over x plus h squared times x squared times 1 over h, because this really is h over 1 over here. Now, to simplify this particular problem, I'm going to then take the limit as h goes to 0 and do x squared minus all it is, which will be x squared plus 2xh plus h squared, alright, all over h times x plus h squared times x squared. Okay? So, now I have my h incorporated into my problem. Okay? At this point, though, what I'm going to do is simplify this even further. So I'm going to get right here, the x squared and the x squared, they cancel out. So what's left is the limit as h goes to 0 of negative 2xh minus h squared. Alright? All over h times x plus h squared times x squared. Okay? At this point, I then can factor out my h. So now it's negative h times 2x plus h. All over h times x plus h squared, and then times x squared. These h's cancel out, and then I'm left with the limit as h goes to 0 of negative 2x minus h all over x plus h squared x squared. Alright? Now, on this particular portion, I then can plug in my 1 value for h, or I'm sorry, my 0 value for h. So I get x squared times x squared. So let me erase some of this stuff real quick. This part right here. So I can write a little bit more. So now, at this point, I now have negative 2x all over x squared times x squared. Okay? And I get equals negative 2x over x to the 4th power, which really turns into negative 2 over x cubed because the x's cancel out, and I get my derivative that I originally had over here. Okay? Sound like a plan? If there's any questions, y'all definitely let me know. Alright? Thank you very much.